Hello, ladies and gentlemen, and today we're going to look at solving equations and inequalities, what you're going to want to have around you right now. You're going to want to have your notes, you're going to want to have a pen or a pencil, and you may need a calculator today just to do some simple addition and subtraction, and possibly multiplication and division. So, here are your learning targets for today. You need to be able to solve multi-step linear equations, solve simple inequalities, solve compound inequalities, and also be able to sketch solutions to an inequality on a number line. What does it mean to solve? Well, to solve an equation is basically to find a solution or solutions that make an equation true. And you're going to find that value that makes a statement true. So normally we see it as x equals 4. So let's actually solve a few equations here. So, very first thing that you're going to do, I have distributive property that I need to do here, right? Need to do some multiplication. So 3 times x is 3x, and 3 times 4 is 12. So I'll get 3x plus 12. Let's distribute this in further. So negative 2x there. Negative 2 times negative 5 is a positive 10. So, very first thing that I got to do, I got to get the x's to one side and the numbers to the other. So I'm going to add 2x to both sides. Wait, 3x plus 2x, that's 5x. There we go. And then got to subtract 12, it looks like. Got to get my numbers away from my x's. So I'm going to get 5x equals negative 2. Now, I got to isolate x. Get x alone. He doesn't play well with others. He needs to be alone. So I'm going to divide by 5. And I'm going to get left with x equals negative 2/5. We're actually going to leave it as the fraction, which is going to be super awesome. Now, what would happen if I plug negative 2/5 in? Well, I'll get a true statement. I'll get one side equals another side, which is wonderful. That's what I want when I solve. That's a good way to check your answer and make sure you did it all right. Let's take a look at this last example of equations. So this 2/7 is probably scaring a few of you. Let's not look at that yet. Let's get that negative 2 out of the way. So I'm going to add 2 to both sides. Got to do the opposite, right? 2/7 x equals 10 plus 2. That's 12. Now, what am I going to do with that 2/7? Well, I'm going to divide by 2/7, which is the same as multiplying by his reciprocal, or 7/2, right? So I'm going to multiply both sides by 7/2. Now, got to multiply our fractions here. We're going to remember here. It looks like I cross cancel, right? 2 can become a 1, 12 can become a 6, because 12 divided by 2 is 6, and 2 divided by 2 is 1. I'm going to get x on this side, because this cancels out to 1. Multiply across. 6 times 7 is 42, and then 1 times 1 is just 1, so I can leave it as just 42. So x equals 42. Not too hard, right? You guys have seen this before. Let's take a look now at the other side of the spectrum, the inequalities. So equations, you notice they had an equal sign in the middle. Inequalities, they have a greater than or a less than sign. If you need some help, if you need to remember that this is greater than and this is less than, I would definitely take a note and write that in your notebook, because that is going to confuse you a little bit if you don't know which sign we're talking about. Steps in solving, you're going to do the same thing. You're going to do inverse operations. So if you see addition, you're going to do subtraction. If you see a multiplication, you got to do some division. Now, there are some special rules that only inequalities need. Notice how there's a little pencil here. You need to write these down. Star them somehow. Just remember them. When you're solving an inequality, you need to, if you happen to divide or multiply by a negative number, you need to flip the inequality sign. You really just got to remember that you got to do that. And you're going to find yourself solving an equation and you're going to realize you didn't do it. Just be careful, keep that in the back of your mind so that when you come to it, you kind of just go, oh yeah, I need to flip. And I'll show you when that happens. And then you also need to be able to sketch your solutions on a number line, which we'll talk about in a little bit. So let's take a look at solving an inequality now. So I got 6x is greater than 32 minus 2x. So what I need to do is basically like I did for the equations. I'm going to get my x's to one side. So I'm going to add 2x to both sides here. 6x plus 2x, well that's just 8x is greater than 32. Gotta get that 8 away from the x. X doesn't play well with others. Right now it's multiplied. Undo that. Let's do division. So I'm going to get x is greater than 32 divided by 8, 4. Now, going to do a double check. Did I divide by a negative at all? I didn't. I didn't multiply by a negative, so I'm good. This is my answer. X is greater than 4. What does that mean? That means if I would plug in for x a 5, a 6, a 7, any of those numbers above 4, I would get a true statement. Now if I plug in 3, or even if I plug in 4, it's not going to work. It's not going to be a true statement. So now what I also need to do is I need to graph it on a number line. Here's how you graph. Put 3 little lines here. Notice how 4, I'm going to put 4 right in the middle there. And then I need to put 2 numbers on each side. So one smaller, 3, and one larger, that's 5. Now, little side table here. Whoops. Let's do a little side note. Why can't I draw over there? There we go. Tablet not working for me here. Notice how it's a greater than symbol. If you ever see a greater than or a less than, you're going to have what's known as an open dot at your number. Open dot basically means you don't fill it in. If you see a greater than, equal to, or a less than or equal to, you need to close that dot. Basically, you're going to fill him in because he also works. He's equal to. So I have a greater than symbol. I can't use him, so I have to open that dot. I can't show that I can use 4. Now, I need to figure out which side am I going to shade. I need to know which side I'm going to go. Do you remember shading? So I need to figure out where are the x's greater than 4. Well, 3 is not greater than 4. 5 is. So I need to go on this side and do some coloring or some scribbling, if you want to call it scribbling, so that I can show that all the numbers greater than 4 on my number line are in that general area. Let's take a look at this problem. So I have 10 is less than or equal to 6 minus 4x. Very first thing, get your x's and your numbers separate. Separate them. So I'm going to subtract 6 here from both sides. I'm going to get 10, ooh, not 10. Silly, silly. That's 4. Is less than or equal to negative 4x, because this cancels, right? Well, negative 4x, I'm going to divide by negative 4. Now, there should be a little warning light behind in your back of your head going, warning, warning, warning. You divided by a negative. Well, divided by a negative. I got to flip that sign around. So I have 4 divided by negative 4, negative 1. And then this sign, instead of being a less than, he's going to now turn into a greater than symbol. And then I get a 1 there, so just x. So negative 1 is my solution. Now, it's kind of hard to read this. Negative 1 is greater than or equal to x. I kind of don't like that. I like when my x is on the left-hand side, and I'll explain why in a minute. So what I'm going to do is I'm going to flip this thing around. So notice how the smaller point of the arrow is pointing to the x. Well, I'm just going to make sure I write it like that. So basically I'm going to change the inequality symbol around. But yet, in the same way, I'm not changing the answer. I'm just flipping it around so the x is on the left. So x is actually less than or equal to negative 1. So I'm going to put negative 1 here. Now I've got to fill both sides. Remember, bigger numbers are on the right. So 0 should be on the right because 0 is bigger than negative 1. You would rather have $0 than negative $1. And then negative 2 is on that side. So I have a less than or equal to, so I'm going to close that dot there at negative 1. Now, here's the big reason why I like the variable on the left. Notice how I need the numbers smaller than negative 1. Well, 0 is not smaller, negative 2 is. So I can shade on that side. Did you notice how I shaded on the side the way the arrow points? That's what's really cool about having a variable on the left-hand side. If you have your variable on the left-hand side, you can just follow the arrow and immediately shade on the side the arrow points. Now, let's take a look at some bigger, badder inequalities called compound inequalities. There are two kinds. One of them is called an AND inequality. This is the top one right here. He's an AND inequality. Notice there's two inequalities basically slapped together to make one big granddaddy inequality. Then I have what's known as an OR inequality. Notice how it's separated by OR. There are two separate problems going on in an OR inequality. So let's take a look at both of them. Alright, so let's take a look at an AND inequality. So normally if you would have seen this, you would have seen that it has that negative 12 is less than. Let's kind of forget about that for a moment. What if you just saw 3x minus 1 is less than or equal to 3? Well, you would have added 1, right? So on both sides, instead of just on that one side, we're actually going to add it to 3 different places. So we're going to add it to every single side of our equation. It's that balance beam thing. We got to make sure we add it to every single area. So negative 12 plus 1, that's negative 11. Still got 3x in the middle there. Is less than or equal to 4. Got to divide by 3 here. I get negative 11 over 3 is less than x, which is less than or equal to 4/3. Now, notice, x is solved for. So now what I want you to do is put my two answers on sides. I know negative 11/3 and 4/3 are right there. Notice I didn't do a third, but that's okay. I didn't put a third number in there. I only needed 2, really. Let's figure out the sign, the open dot or closed dot. Well, I know I have a less than symbol, so I'm going to have an open dot at negative 11/3. And then I'm going to have a closed dot at 4/3 there. Now, let's figure out which way am I going to go. So read from the variable. I know x is greater than negative 11/3. If he's greater than, he has to go this way. Okay? And if x is less than or equal to 4/3, he's got to go that way. Notice how they're both in the middle. That is actually something that AND inequalities will do almost 95% of the time. You will see them always go towards each other on their graph. Sometimes, rarely though, they'll go away from each other. The graph that goes away from each other is usually what's known as the OR inequality. So notice how this is two completely different problems, separate from each other. What you can do is basically solve one and then solve the other, just like you normally did earlier. So let's treat this one as its own problem. I'm going to subtract 5 from both sides. I'm going to get negative 9x is less than 14 minus 5, which is 9. Then I got to divide by negative 9. Now, there should be a little warning light in the back of your head going, warning, 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 dividing by negative. So I'm going to get x is less than 9 divided by negative 9. Oh, my warning light didn't work very well, did it? Should have flipped that sign. There we go. 9 divided by negative 9, well, that's negative 1. So I got one of my answers there. And then I got to add 17 to both sides to start solving this particular inequality. Going to get negative 4x is greater than 20. Divide by negative 4. I'm dividing by another negative. I just heard a warning light in the back of my mind. So I'm going to go x is, instead of greater than, I'm now less than, negative 5. So I have both of my solutions. X is greater than negative 1, or x could be less than negative 5. So I got negative 5 here and a negative 1 there. Put them on the number line where they should be. Negative 5 should be on the left of negative 1. And then let's put in our signs, or our dots. I know they're both open because I don't have a greater than or equal to, so I can just put open dots. And then x is greater than negative 1. If he's greater than negative 1, he needs to go this way. And if x is less than negative 5, he needs to go that way. Notice, they're going away from each other. Or inequalities, just like AND, is about 95% of the time you will see them go away from each other. That is a very common thing to see. Now, does it happen all the time? No, but it's very rare that it does not happen in that form. And that's the end of this video. See you later, Sabers.